Thank you, Joe. So before we go over how to establish the selection rules, we'll look at how we can also apply these knowledge bases in 3-axis operations as well. Now, you could do this for 2, 3, 4, and 5-axis operations. The workflow of knowledge base that works very similar. So let's take a look at an example for a 3-axis, and then we'll switch back to this part and we'll talk about how we can specify rules for selection. So I'm going to bring in a part that has a cavity, and this particular part, the cavity, has sculpted features. You can see drafts, you can see fillets. So parts like these would require programming using 3-axis operations. So I currently have several operations programmed on these. I have a roughing operation, I have a parallel finishing operation, I also have a horizontal finishing operation. Now, if you would like to exclude some of these operations, you can just right-click and select Cut if you want to remove an operation from your operation tree. Now, I have 2 operations in here, and I'm going to save these 2 operations to a knowledge base. Exactly the same steps as we did in the 2-axis programming of prismatic parts. I'm going to save this as part cavity and save it under the data folder. So the knowledge base now contains information about the 2 operations, has information of all of our parameters, like the cut parameters, entry and exit, clearance, your tool, feeds and speeds, and it also has information about your machine definition and the post processor as well. So if the machine type is set to 3-axis or 4 or 5, the knowledge base will have information about that as well. So you don't have to go through the process of redefining your machine definition when you load the knowledge base in another part. Now, I'm going to go ahead and load in another part. So I'm going to go ahead and load in a cavity part in here. Now, the part that you're seeing that is being loaded is not similar to what we had programmed in the previous step, but it is a cavity mold, and I want to make sure that the previous part I saved to a knowledge base I worked on was in inch units or English units. So I want to make sure that the knowledge base I'm loading and the model units of the part is in the same unit. So here the part I'm working on is in metric units, which is millimeters. I need to make sure that I change the units to inches before I load the knowledge base. So you need to make sure before loading the knowledge base, your model units is in the same units as the units in which your knowledge base is saved in. So I'm going to select the units to inch. I'm going to scale the part, and now the model is now scaled to inch units. So I have this cavity mold ready. I would like to go ahead and program it. So rather than having to create these operations by going through the menu, I'm going to load the knowledge base that I just saved by going to Load Knowledge Base. And you can find this Load Knowledge Base right under your Program tab in the machining browser. And you would select Load Knowledge Base. And I'm going to select the knowledge base I had just saved, which is called Part Cavity. And I'm going to pick Open. And you'll notice that the 2 operations I had saved are automatically loaded in here. Now, in this particular step, I'm just going to right-click and regenerate. Now, as I'm not specifying or using any containment regions, the toolpaths in the 3-axis mode are automatically generated. As you know, programming in 3-axis, does not necessitate to have you select control geometry at all times. So your workflow is a lot faster. So in just 2 button clicks, loading the knowledge base and regenerating, we now have the roughing and the parallel finishing toolpath programmed on this particular part. Now, if you need to use containment regions, you can always select the containment regions by editing the operation, and you can go ahead and select containment regions from the control geometry tab. So you have the same level of control for editing. Like you edit an operation, you can edit the operation after you load the knowledge base to go back and select features. So here I use an example of a cavity mold. So I loaded a new mold. I was able to bring in the same knowledge base and program it. Now it's not just limited to cavity parts. You could use core features, any 3D geometry that you need to program. So here I have an example of a core. So we programmed a cavity. We saved the operations to a knowledge base that were programmed from the cavity. Now I'm going to load the same knowledge base on a core mold as well. And I'm going to use the same knowledge base to be loaded, the one I had just saved a couple of minutes ago. I'm going to open it. and I'm going to select the setup, right-click, and generate. Now, one thing I want to point out before regenerating, you'll notice that the stock geometry is not defined by default when you bring in a new part. So when you load a knowledge base and regenerate your roughing operation, the stock is automatically defined as a part box stock. It takes into account the bounding extents of your part and defines a part box stock in here. And you'll notice that the stock is now automatically defined when the roughing operation was generated or regenerated. If you need to go back and make changes, you can redefine your stock, and all you got to do is regenerate the machining operation. So you could automate your programming workflow by saving operations to a knowledge base and reutilizing these knowledge bases on family of parts or parts that require a similar programming workflow. So this would save you several I would say hours of time in case where you have tens and several multiple machining operations. So it just makes it easier, and you have a proven way of establishing your tool, feeds and speeds, and all the parameters. You don't have to go back and revalidate each of these parameters to make sure that if you've set it right. So loading it from a knowledge base brings all the parameters in from the knowledge base to the operation that you're programming. So this saving and loading of knowledge bases can be used for 2-axis, 3, 4, and 5-axis operations as well.